All right, ladies and gentlemen, we're continuing with section 3.2 in my college algebra class. We have the equation 2x squared equals 6x, and we're asked to solve it. Now, so far in this section, we've used the method of factoring, the ZF property, and we've also used the square root property. This equation is not conducive to the square root property because there is an x that's just I call it free floating. So this is not going to work with the square root property the way it is. So I'm going to try solving this equation by the zero factor method. First step is to put the equation in standard form. So that would become 2x squared minus 6x equals 0. So that's what the z means. Set it equal to 0, which is really standard form. Descending power order, leading coefficients positive. Next thing we do is factor. Well, here, the greatest common factor is 2x. In parens, I would be left with x minus 3. And now I actually apply the zero factor property, what basically says if two quantities are multiplied together to give me 0, then either the first quantity is 0, first factor is 0, or, and that word or is important, the second factor is 0. In the first case, we divide by 2. 0 divided by 2 is 0. So one answer or solution of this equation is x equals 0. Here, when I add 3 to both sides, x is 3. So this quadratic equation has two roots, namely 0 and 3. And when I use the term root, that's just a synonym for solution. Okay? A root of an equation is a solution of an equation. All right, let's look here at this one. We're solving 3x cubed plus x squared minus 12x minus 4 equals 0. First thing I want you to know here, when you see degree 3, this is no longer called a quadratic, this is called a cubic equation. And in general, when I have a cubic equation, I am going to have up to 3 solutions. No more than 3. Okay? Now, one side's already set equal to 0, so the ZF property is very good to use here. It's in standard form already. You know, descending power order equals 0, leading coefficient is positive. Whenever I see 4 terms, I hope a technique that comes to your mind from the past is factoring by grouping. So we're going to group by 2's. When I group the first 2, I can factor out an x squared. In parens, I would have 3x plus 1. When I group the second, I factor out a negative 4, and in parens, I have a 3x plus 1. This has to be a plus because negative times positive will give me a negative. Now, notice, people, here's one term, here's a second term. I still, of course, have my equals 0. That's important to write, equals 0. But these two terms share a common factor of 3x plus 1. 3x plus 1 factors out as my greatest common factor. X squared minus 4 is left over. Okay? Now, this is done, but x squared minus 4 can factor as x plus 2 times x minus 2. So on this one, I'm basically just going to factor till I drop. Okay? 3 factors multiplied together to give me 0, so this time when I set up my cases, there's 3 of them. 3x plus 1 is 0, or x plus 2 is 0, or x minus 2 is 0. In this first case, I subtract 1. 3x is negative 1, and I divide by 3. So one of my solutions is negative 1/3. And this is simple. We subtract 2. So we get a solution of negative 2. And in this case, we add 2. So we get a solution of positive 2. So this equation has 3 solutions or roots, which is not shocking since it was a cubic equation, meaning it was degree 3. So the important thing on this problem to remember was the technique of factoring by grouping, which is usually the catalyst for that is when you see 4 terms in an expression that you're trying to factor. And we're done.